Well, welcome everyone to our session on FAIR for AI in Geosciences. This is a joint session between Machine Learning Cluster, Data Readiness Cluster, as well as the newly founded NSF Research Coordination Network for FAIR in Machine Learning AI Readiness and Reproducibility, RCN, FAR RCN. So you'll hear from each, from Machine Learning Cluster, as well from FAR, and two invited speakers from domain outside of geoscience to share their perspective on FAIR for ML and how that advanced open science. Let me start sharing my screen now, finally, after I deal with the emails.
Douglas, feel free to have her contact our team if there is a challenge getting in, and we could help out with that.
Yeah, I just sent her the Zoom link directly, so hopefully that will right.
All right, great.
And let me go into the slides now. I would like to invite everyone to go into this Mentimeter link that Annie are gonna help post in the chat. We want to understand who is in our session today. And, oh, right. So first of all, I want to see what's your role in the AI machine learning development overall. So, or you can go to menti.com using the code 64677752. This is also linked in the agenda document as well. So you can go into the agenda document, go to the Menti link. Let's see who we have today in the session. We have practitioners, we have data managers, providers, and program managers, and founders, and curious observer, which is the single large group so far. And AI, well, we don't have any end users for this session right now. But yeah, let's wait for a few, another minute to see we have more people joining the session right now. So if you need, go to menti.com using the code 64677752. You will see the this poll. We're trying to see who we have in the session, and that can help us inform our discussion later on. All right, I think I'm gonna move on to the next session, next slides. Now, since the session title name is FAIR for AI in Geoscience, and want to see how people feel about their knowledge and understanding of FAIR in AI ML. So there are 5 answers. You can use a slider to choose your comfort level about this. And not quite sure overall for FAIR in AI ML, but maybe you're familiar with FAIR data, FAIR software, FAIR virtual lab, computing environments, or FAIR workflows, etc. So feel free to put in your answers here. Let's see who do we have here in the discussion for FAIR in ML discussion today. I always like to see the spider web change all the time. For people who just joined, you can go to menti.com using the code 64677752. Let's see if we can get to more than 25 responses this time. It's not surprising people are more familiar with the FAIR data, because that's when the FAIR principle first came out in the 2016, is that? I couldn't remember exact year. Okay, let's wait for another 30 seconds. Seems like people don't quite sure about FAIR for virtual labs. Maybe Christine or somebody want to promote the RDA group in the chat at some point.
Yeah, I can provide a link to that because there is a community that's active.
Yep, great. Thanks, Christine. Awesome. And thanks for all the response. Let us know who are in our session today. And I just want to give a quick overview and a background about why we are doing this session. So within ESEP, there are different groups. I am co-chairing the data readiness group, and that's a group convening different representations from agencies, private sectors, and academia, trying to understand the user's data needs for AI ML research and development, with particularly focused on environmental data, and also trying to develop guidelines, leading practices, and tools for AIReady data. And thanks to Allison's help, we have blog post up talking about our AIReady checklist, and also some explaining our roadmaps of how we want to achieve the AIReady data efforts. And in terms of FAIR for machine learning and AI, there are different groups that might be relevant. So for ESEP, there's machine learning and there's data readiness cluster. And within different agencies, for example, USGS, the CDI has an AI ML group, and NOAA has an AI community practice. And the lead for the NOAA Center for AI, Rob Redman, is also a co-convener for this session, who is in the session today as well. And within the Research Data Alliance, there's a FAIR for machine learning interest group. Just I think the webpage is also live now for people who can sign up. And with nonprofits and other industry partners, there's also the Radiance Machine Learning ML Hub, which is a place where people deposit those AI training data sets and also models in the platforms. And now today we also have a representation from the ML Commons. You'll hear more from Jeffrey about ML Commons and their specifically science working group. And in the industry, there's also the Hugging Face, which they represent a lot of development in the AI development for the future. And also there's a newly established research coordination network by ASF, led by Christine and some colleagues, including myself as co-PI for focusing on the FAIR in ML, AI readiness, and reproducibility. So the whole purpose of this session is trying to figure out what do we have here and what do we have today and what we are working on to advance the FAIR for AI and machine learning, and what we are not having or what we are missing right now, and what's challenge to achieve FAIR for AI and machine learning. And through the community collaboration, can we really move from what we don't have side, move things from what we don't have side to what we have side. So that's the whole motivation of the session today. And that's why we are really excited to have the collaboration between machine learning cluster, data readiness cluster, and the FAR RC here today. And that's just a quick overview and background of the session. And with that, our session today have 4 speakers and to present from different perspectives on the FAIR for AI and machine learning. Sorry for the background dog noise. And after that, we'll have a discussion and to figure out what the have and have-nots and how we as a group and community can work together to advance the FAIR for AI and ML. And now the first speaker would be Dr. Jensen Sung from George Mason University. His title is GeoWeaver, make Earth's AI workflow tangible. Jensen?
Yeah, thanks, Yuhan. Let me share my screen. See if it works. All right, so let me kick off the timer. Otherwise, I will go on and on. Hello, everyone. This is Zihan Jensen from George Mason University. I'm going to talk about the GeoWeaver and how to make AI workflows tangible, which probably it's not new. Actually, it's still within the scope of the FAIR, but we have to came up with a system to measure how fair. It's like, is it fair enough to improve the entire community's efficiency? And yeah, let's dive into that. And I could be wrong. So if I made some mistake, just please correct me. This project is actually sponsored by many sponsors. Many thanks to the ECIP lab, the Access, NASA Access, NSF Geosmart, actually NSF Cyber Training Program, and the Geoinformatics Program. So yeah, where are we now? It's like the AI research in earth science is not something new. It has been going on for like decades. But so what's our progress of making the LCI practical? And do you feel the change, the benefit and advantage brought by AI in your daily life? Probably not. It's still in the early stage and the prototyping stage. Even we have like spent many hours and many years of effort, but it's still starting stage. But comparing to the computer science area, it's actually industry area. We didn't feel the excitement like when something like ChatGPT came out and everybody is stunned. It's like so powerful, but it's not magic actually. We can't achieve that similar results using the well-planned and the step-by-step work to achieve that kind of same thing. But still, I think even though we have spent so many times and so many fundings on the different projects, we still kind of like falling behind the current progress of the AI research. So my answer is going to be no. So I didn't feel that kind of excitement as same as some other like industry projects, AI projects came out. And in the literature, obviously, we have seen a lot of AI papers come out in all kinds and like all subdomains of the earth science, like LCS, LU, the hydrology, slow mapping or sweep forecasting, air quality, earthquakes, wildfire. But I would say maybe a few of them already became a product, but most of them are just staying in the papers, and people are just still feeling like very hard to replicate those research. That's the problem. Yeah, overall the AI progress is pretty slow based on my observation. I could be wrong, but it's pretty slow, even though we're talking about AI in all kinds of places, but yeah, the progress is really not substantial. So what causes the slowness in our AI research? If you look into the industry website, like the AI project website, and like ChatGPT, actually all the details, like technical details, are not that advanced. All these steps, actually, we all know about them. We have the same kind of knowledge, we have the same technology, but why they can achieve this kind of success, but we can't? That's really a funding question about how to solve the problem of the AI progress right now, and make sure that the community can work together and achieve the bigger success as a whole. So I think I personally conclude the 3 points, and which probably is not comprehensive, but I think it's the most important one from my perspective, because I have been working on several AI projects right now, and these are mostly 3 things that mostly bother me, and also dragging us behind and slowing us down. So first one is the sharing challenge of the training data, which we all know about that. Most of the training data is not public, is not shared by the original publishers, like the paper authors. They'd rather keep them a secret, probably. That is understandable, because not all the public funded projects can share all of the data. But we're gonna encourage everybody just to make their data fair, so other people can replicate them, not only just reading your papers, but also can continue your work. Standing on each other's shoulders is the most important thing for the science to advance. The second one is even people are willing to share, we still lack of the full stack AI workflows, which is even important because everybody is so busy that if your work like missing some important parts, no one is gonna have the time to just fixing them again, like spending the same amount of time to do all the workflows again. So sharing full stack, please, sharing full stack AI workflows with your colleagues. Because we already know that there is a crisis of the replication of the AI results in the science, and we don't want the worst that situation. So we need to fund it. Actually, most people are using like scripting. So all their scripts and data are actually scattered, are not well managed. So it's not they are not willing to share, but they don't have that kind of tool to help them package everything and share with other people. It's kind of complicated. And third one is the high onboarding cost to reuse existing AI workflows. So some colleagues publish the notebook and the data on the GitHub. So how long will it take you to just reuse it? That is kind of the onboarding cost. Even in the same team, if you have a new colleague come in, and how long it will take you to train them to start contributing. And that's the most important part, actually. Sometimes it takes 1 year and those people still not contribute, just learning. So the speed from the learning to the contributors is one of the main issues that's slowing us down. So what we want to do is first make the data fair. Second is make the workflow fair. And the third one, we need to make the workflow tangible, because people should be able to, it should be easy to reuse your workflow, not only fair, but should be fair enough to be easy to reuse. So that's related to our title, like what is tangible, like why it matters. I think tangible can be interpreted in different ways. I'm even not sure about this is the right word. I think it's the best word I can choose to express what I mean. So tangibility means how easily your AI workflow can be reused by other peers, even the students without background knowledge, or the other earth scientists, your peer scientist who has same science domain background and the same amount of Python knowledge. How easy can they reuse your workflow? How much of the time they're gonna invest if you decide to replicate your results? So how do you measure that? You can consider that tangibility almost equals to the cost of the onboarding people to run your AI workflows. Sometimes it will take like many months, several months. And if you do it right, you could onboarding people in like 2 weeks. That's what we did. Like GeoWeaver is really helping us. So I would like to share with them. So onboarding is the most important part, and it's mostly concerning us because all the most of the team members are students, and they come and go, and if they spend like the whole semester learning your AI workflows, they are not going to contribute to the science at all. So we have to find a way for them to like quickly understand what you are doing, rerun your workflows on their laptops and start to revising the single steps and modifying the models, tuning the hyperparameters, and started contributing. So we needed to reduce this cost and make the AI workflow more tangible. Here is actually a flow graph. So you should ask yourself the question: are your workflows fair? If it's not, and then it means only existing in the literature, and its value is really not that big. And if it is fair, it's a yes, then you should ask: are your AI workflows tangible? If it's not, then the whole community is actually slowing down because it takes too long to reuse your workflows. But if yes, that means we will achieve the practical OCR very soon. So that is very good promising vision in the future. Like OCR helping the scientists to do the real science like much quicker than 20 years ago. That is really exciting. So GeoWeaver is the solution we got. It's a software we developed originally based on the ECIP lab project, and now it's funded by NASA Access and NSF. It's basically like a productivity tool. It helps you to organize all your Python scripts and run it somewhere else and store the history and the source code in one place. So for the original flowchart, if your workflows are not fair, you probably should consider using use GeoWeaver to make it fair, and then it will directly make it's not like a notebook. It's actually production ready, so you can make your workflow instantly. If you have the resources, you can run it every day using GeoWeaver command line, and produce the AI result that can actually be used. Oh, I don't have time. Sorry, I'm gonna go quick. So if it's tangible, then you should use it to make it tangible. And this is the example we have, and you can check out this website we made for the CMAC AI. And the research to production took us 1 year, and students onboarding average time is like 1 to 2 weeks. It's very soon. It's like those students have no background of the earth science, but they are pretty sure they can understand these workflows very quickly because it's a graph. It's not they don't need reading or understanding the source code. It's a flow, so it's much easier to understand. And this is how the GeoWeaver is being used. So I'm going to skip this one. So what's the next? Welcome to join the ECIP machine learning cluster, as you mentioned. We are a group that is dedicated to like brainstorm what AI should look like and publishing some community-wide papers like this one. This one already has been became one of the most downloaded paper of this journal. And also we think that AI practitioners should be in the driver's seat. So we should make some bold attempts. And we also have this GeoSmart curriculum and tutorials that will be public in the GitHub, so everybody can use it. And it covers a lot of use cases across the geoscience, hydrology, and the seismology. So welcome to check it out. And that's it. Thank you so much.
Right. Thanks, Jensen. If you have questions, please put them into the Menti link that I sent in the chat, and then we will have a discussion after all the speakers have presented. And Jensen will leave us for a half hour and then come back joining us later on. So with that, I want to turn it over to, I believe it's KJ. KJ, are you online?
Yep, I'm here.
Yep, please, can you share your screen?
Yes.
KJ Schmidt is with University of Chicago and working with Globus Lab and other her talk title will be Software Tools to Achieve Fair and Open Science. And when you are ready, I'm going to start a timer.
Okay, I just want to make sure I'm sharing the right window. Okay, then I'll get this in presentation mode. Okay, and I just want to double check you all can see the slides.
Yeah, it looks great.
Okay, perfect. Okay, then I will go ahead and get started. So my name is KJ Schmidt. I'm a research scientist at U Chicago and Argonne National Lab, and I'm here to talk about software tools to achieve fair and open science. Before I get into that, I just want to say thank you to my team. The team is really awesome, and everybody on this slide has had their hands in the software that I'm about to go into. And yeah, they're just awesome to work with. So I just wanted to start with a little shout out to all of them. Okay, so I wanted to start by asking, what does getting access to data or getting a machine learning model up and running look like in your workflows? And I'm going to guess that it looks something like this for a data set, which is, you find this data set you want to use. You are contacting the authors maybe, or you're finding little subsets, or it's this large file, you can't figure out how to get your hands on it. And more often than not, you end up at this last one of you can't get it working, so you cut your losses and you move on. And with a machine learning model, oftentimes, you find that machine learning model you want to use. Maybe you find a GitHub repo, you try to get that running. There are dependency issues, there are files missing. Reach out to the authors, maybe not, you hear back. And so again, more often than not, you end up at this last bubble of you can't get it working, you cut your losses and you move on. And these are both really frustrating processes, and they're also really time consuming. So I want to ask the question, what do these processes look like when using tools that focus on fair data practices? And you may not have an answer to this, but this is what our team envisions. So a workflow with our fair software tools would be, you found a data set or model that you'd like to use, you install one of our software packages, and then you can just load the data set or model with the DOI or short name, and you've got it working. That simple, straightforward. So introducing the software that we are building to make that happen. So we have Foundry ML and Garden. So Foundry ML is individual machine learning ready data sets, and Garden is a full machine learning ecosystem with all the pieces that you need to get a model working. Okay, so let's dive into Foundry ML first. So Foundry ML is an open source machine learning platform for scientists. It focuses on accessibility, reproducibility, and collaboration within research. It's built with Python, which I'm sure many of you are familiar with because that's a very popular programming language for machine learning right now. And Foundry ML makes accessing and sharing large data sets fast and easy. So we've created our infrastructure with sharing large data sets in mind. So how is this useful for researchers like you? So the advantages of publishing your data with Foundry ML is that you can easily share your work. It's really easy to build off of your work in the future, and publishing is free and it helps get your work in front of more people. So we have a website that has, I think, really beautiful UI that's easy to use. And so people can easily just browse the data sets and discover your data set. And also your data set gets its own page with all the information about your data set and how to use it, how to get started with it. So when you want to share your work, you can just copy and paste that link, share it with people, and that's it. And for using data on Foundry ML, the advantages of that is that it significantly decreases development time for you. All of the data sets that we have, have taken months to put together, to clean the data, to format it, to get it machine learning ready. And that time is completely taken out of your development cycle. You have the ability to load data sets that are too large to share in common infrastructures like GitHub or Dropbox. And you can immediately understand a data set with our descriptive metadata. So I'll get more into this in a little bit, but we have descriptive metadata for every single one of our data sets that's required to be filled out by the author. That helps you understand what exactly is going on when you open that. So Foundry ML gives you access to highly structured machine learning ready data sets. We have about 30 right now. And on this screenshot, this image on the right is a screenshot from our website. And this is a data set page. You can see the title and the authors. It's got some information about the data set. And then there's this little code block down here. It's 4 lines of code. And with that 4 lines of code, you can access 1.9 million entries of this data set. And that is all you need to get up and going. So you might be thinking, is it really this easy? And yes, it actually is. So you can load metadata and data with just 2 lines of code. So that first line of code, you're loading the data set with the DOI, and that will return the descriptive metadata. And then that second line actually loads the data into the client in its machine learning ready format. So once you load it in, you are ready to go and start working with it. All right, so our descriptive metadata, this is an example. It's a little bit shorter, so I could fit it on this slide, but it hits the main points. So again, this is We have required metadata for every single one of our data sets. The authors fill this out in order to be published with us. So we'll just go through this. That there's the title on top, and then outlined in blue, you have all the data set keys with more information. So we've got the key name, we've got the type, which would be input or target, we've got units if that's applicable, and then we've got a little description. When you go down to what's outlined in pink, you have split details, if this is like a train split or a test split. And then the rest of that data set information is outlined in green, like data type, this one's tabular, task type, domain, the amount of items in this data set. So once you get used to reading this table, you can really easily understand every single data set that we have, because it's all formatted this way, making it super easy to understand data sets right away. So here is a full Foundry ML workflow created by our colleagues at MIT. So it fits on just one slide, and that's how simple it is. So this is the OSDA database. And so you can see in step A, you want to load the data set information. First, you import Foundry, then you instantiate, and then you'll load the data set with that DOI. And once you run the f.load with the DOI, you get back the descriptive metadata. So in step B, you learn about the data set contents. There's that table again, looks familiar. And then C, you download and use the data set. So you'll do f.load data, that loads it into the client. And then with this, with that next line, you're loading the training split, putting input target, or sorry, input keys into X and target keys into Y, and then just seeing that data below. And this chart here at the bottom is actually from a paper that they published about this database. And it's super easy to recreate that and the other charts that they have in this paper. We actually have a Jupyter notebook that you can run. It's on our GitHub in our examples folder. And it walks you through loading the data set, playing around with the data, and recreating all of the charts that they have in their paper. So now that you've seen a full end-to-end workflow with Foundry ML, let's get into Garden. So this is Garden. It's currently in very early stages of development, but Garden is a full machine learning ecosystem for a particular topic. So it's a holistic approach to machine learning using FAIR principles, and it makes building off of existing machine learning research significantly easier and faster. And it fosters community building around domain problems of interest. So how does Garden help researchers? So it helps in 4 key ways with reproducibility, accessibility, quality, and community. So in reproducibility, you have all the pieces to reproduce and build off of any garden. For accessibility, you have code, data, testing, all of this is available and it's free, so there's no barrier to access. And you can also run models using our compute resources at UChicago or any FuncX endpoint. Quality, we have testing included in each garden, so you can test and evaluate models without the time investment of doing that all yourself. And community, you can find your machine learning community, collaborate, and set new benchmarks within your domain. So I guess this will put together the piece of what a garden really looks like. So like I said, a garden is a full machine learning ecosystem for a particular topic. So garden includes links to data, groups of models, functions that are necessary to the machine learning pipeline, like pre and post processing, automated quality testing, citable objects for the garden and each model, and then anything else a model needs to run and be evaluated. So because we found that just having a model file won't get you where you want to go, there's usually a lot more code that goes into reproducing a full machine learning pipeline to get the desired output. So the images we have on the right, we have this top image is the beginning of an example garden card. So this garden is molecular property prediction. It would have a group of models that predict different molecular properties. And then we have testing below. This is what we envision testing would look like. You can see we have software testing, reliability testing, and performance testing. So you can evaluate a model or a full garden before you take the time to actually try to implement that model and make sure it's working. So Foundry ML, if that was interesting to you, if any of this was interesting to you, follow or check out the Foundry ML website. So you can browse data sets, look at examples, or look through our documentation. So that's foundry-ml.org. And then Garden is still under development, so I don't have a website for that one yet. But if you'd like to get involved, either building gardens or contributing to the code base at all, please email me. It's just kjschmidt@uchicago.edu. We've started Foundry ML more in materials science and chemistry, but we're trying to expand into other domains. So if you have any interest in publishing with us, or if you have any questions about like what limitations or anything that it's specific to your data, please reach out. We are so happy to talk to you about that. So both projects are open source. So you can help us build or give us feedback on GitHub. Yeah, we'd love to hear from you. And that's all I have. So thank you.
Right. Thank you so much. Perfect timing, 12 minutes. Thanks, KJ. And we have some questions coming into the Mentimeter. So I'm reminding everyone, please keep the question coming. And our next speaker, we will have a discussion after this, after the last two speakers. Next speaker will be Jeffrey Fox from University of Virginia, as well as the co-chair for the ML Commons Machine Science Working Group. Jeffrey, do you want to start sharing your screen?
Okay, can you see my screen?
Perfect, yes.
All right, so okay, let me get started. So I will start off with the comments on ML Commons. And its ML Commons is summarized in this slide. We have at the left-hand side, we have a diagram of the effort, and there's various details about it. It has 2,000 members, 62 companies, a lot of DOE labs, and not so many universities, only 11 universities, and it's built around working groups. There are around 15 working group meetings every week, and there are community meetings every quarter. And on the left, you see the various parts of ML Commons. The sort of heart of it is the training working group, and that includes a subset of HPC training. There is a data sets working group. They generate new data sets, mainly in the speech area at the moment, and speech and image area, because those are the ones that are possibly most dominantly important for industry. There's a best practices working group, which looks on software. And the inference working group has mobile and tiny components. And one part of the working of ML Commons is research, and their science is part of that. There's a medical, which mainly does federated learning. There's the algorithms, which looks at new algorithms. Storage is pretty interesting because at least in my experience, a lot of the performance of machine learning is dominated by how the storage is set up. And ML Commons was set up just not so long ago, December 2020, but it was started off as ML Perf, which was a couple of years earlier. And it has this various laudable goals, such as growing machine learning markets and making the world a better place, and various other related topics. The science working group is led by me and people from the Rutherford Appleton lab in England. And ML Commons research is led by a Harvard computer science professor, Janarpa Reddy, and also shared with somebody from Toronto. So these are the important topics in ML Commons, which is not unrelated, say, to the previous talks. We have data sets, benchmarking, and which includes models, and then best practices, which is effectively sort of the types of things which are recently discussed with GeoWeaver and Garden, and about how best to do things. And they have software products in that area, which the best known is called ML Cube, which is a container technology for machine learning. So here's a few, I probably might have said most of these. We have these three areas. The benchmarks are the ones in science, they're measured by, if you like, a measure of scientific discovery, whereas the benchmarks for the other working groups are measure performance, machine performance, and they cover all these areas. So it's actually pretty important that we have, because they have ontologies for the data, the models, and also the measured performance and running. So that's they do not actually have an explicit commitment, to be fair, but they do have an explicit commitment to log data, and they will not accept any contributions to ML Commons unless there's appropriate logging. Something which is sort of maybe obvious, but although it's called MLPerf, essentially every benchmark is deep learning, more than 90%. I think maybe there's one non-deep learning benchmark, that's it, and that was in the inference area. Everything else is deep learning. And we're working on trying to improve the academic involvement and the science involvement in ML Commons. Remember, ML Commons has got a pretty large industry investment. They're meant to be around 50 full-time equivalent people working on ML Commons, and those are all contributed by the industry members. And because industry, this is all meant to be non-proprietary work. So industry is trying to develop non-proprietary technologies and measurements which will help the industry as a whole advance. It's sort of quite interesting that they distinguish clouds and clusters, but their clouds are quite big. Namely, if you look at their so-called cloud results, they have things which I will call a supercomputer, 4,000 A100s running on a single job from Google. You'll have TPUs, and those are actually larger than many of the supercomputers used in the HPC benchmarks. And it's important, which reflects this particular meeting. There's as much emphasis on data sets as there are on models, and there are explicit data set, and I mentioned data set and storage working groups, which are relevant solely for the data. I find that this activity is, I think, the best activity I've ever had, which has been involved in industry, and that you speak to people from industry sort of continuously and through these meetings. And these industry people are actually, given the recent substantial hiring of people from DOE labs and academia, a lot of these industry people come with this huge expertise on running jobs fast, on making GPUs and parallel computers run real well. I think they have a pretty interesting, good community model. It's probably, I think ESIT probably has at least as good a model, but it's worth noticing that their model, that they have a working community model, which is effective. And I've already mentioned the important ontologies. I would like to personally say, I don't think there's agreement on ontologies. So I'm not quite certain how you can generate totally useful, fair ecosystems until you agree on ontologies. And certainly ML Commons doesn't think there's agreement. Also, I think the progress is not, progress in this field is certainly held up somewhat by the rapid technology change, like TensorFlow has now been almost deprecated and replaced by PyTorch. Well, that's all happened over the last 2 years. And over the last 5 years, deep learning has come to dominate over other machine learning. So we're in a period of remarkable rapid change. So here is a summary of the science benchmarks in ML Commons. Those come through these 2 working groups, the science working group, which I set up, and we'll continue. We've now been operational for about a couple of years, and it has 4 benchmarks summarized around the edge of this transparency: 1 on satellite images, 1 on earthquake analysis, 1 on material science analysis of electron microscope data, and 1 on drug discovery. There are also 3 HPC science working groups: CosmoFlow, DeepCAN, and OpenCatalyst. They're also adding OpenFold, which is the open version of the AlphaFold activity from Google. And we're also adding several benchmarks to science with a couple of surrogates, scientific simulation surrogates as being the next 2 contributions there. I had a couple of remarks on this earthquake benchmark, which I developed, because that is sort of earth science. And I think it's sort of interesting that it illustrates that machine learning and artificial intelligence does capture hidden variables. So although it's well known that the earthquakes effectively occur at a Poisson distribution and randomly, but so do other things, and you can actually learn from the smaller earthquakes to predict the larger earthquakes. And that's how this particular deep learning model for earthquake prediction works. And I'll skip over that. So the last couple of slides I wanted to take to look forward to is so-called foundation models. The first speaker mentioned ChatGPT. Well, that's sort of a foundation model. It's a giant model which has learned everything. So I think it is reasonably relevant to try to set up activities that lead to foundation models, because those have been the ones that have succeeded in industry. And if you look at science, you can sort of find various possible foundation models. If you look at those 7 benchmarks we had in science benchmarks in ML Commons, 4 of those are image-based. They're using ResNet and UNet and things like that. There are graph-based systems, dense synthesis systems that's used in the UNO drug discovery benchmark. Time series, that's this earthquake is a time series, and there are other obviously time series are hugely important in earth science. And there are also, my slides include various AI-generated images. Those come from diffusion models. And I already mentioned the importance of surrogate models where you can learn simulations. So I think a good aim for these types of activities is to try to put enough data sets together of a similar type, say enough time series data to generate such foundation models. And I'll stop there. I think that's a good place to stop my talk. Thank you.
Thanks, Geoffrey. You actually have 1 more minute, but
and I have one more slide, but I think it's best to stop here.
All right. Thanks. We can have a discussion using this 1 extra minute. And our final speaker before our discussion, some community contribution, is the Christine Kirkpatrick from San Diego Supercomputing Center and the PI for the Research Coordination Network funded by NSF on FAIR in ML. Go ahead, Christine.
Thanks so much, Douglas, and thanks for organizing this session. I've really enjoyed all of the talk so far. Just a quick intro to our RCN called FAR. This is under the program at NSF called FAIR in Open Science, that's sometimes referred to as FAIROS. And what's exciting about it is it lets us look at something from the lens of FAIR in Open Science rather than having that be the add-on to another larger grant. And so we've got 3 themes that we're focusing on here in the top right: AI readiness, AI reproducibility, and the relationship of FAIR and machine learning. And here's some things that motivated us to band together and to draw the community in to talk about these things. We know that most of the time spent with data, and especially even with machine learning, is data wrangling, finding it, cleaning it. And so we want to explore the relationship between the FAIR principles in saving people time and looking at, is there any added efficiency also with the processing? People talk about AI readiness, and that can mean a variety of things. I think in our community, we're interested in what that means for data, but there's not much in the literature on what that would mean for a repository. And so building on our relationship to EarthQ and the Council of Data Facilities, Karen Stocks is leading up this effort to engage with Council of Data Facilities repositories, but any others, and doesn't have to be Geo, but that's where our initial focus is. What does it mean? And then as well, how does that differ from an organization to be AI ready? And especially for repositories, what added services or practices or things that you're asking when people deposit data, how would that change? Douglas is leading up the theme on AI reproducibility. And what we'd like to do here is gather, we're trying not to say best practices, but community practices. What are the things that are done within Geo, but also in computer science? Are there things that other people have found that are easy to replicate? And across all of these, what are the gaps in current knowledge? Where should new research be pointed? What is the community wanting? So to that end, we have this research coordinating network that goes on for 3 years. We're again pointed at the of the way NSF is funded, the Geo Directorate and the SCIES Directorate. And our stakeholders include researchers, but also cyber infrastructure providers, and especially people who host repositories. Our goal is to help promote better practices for AI. Shouldn't be so hard to do these things, and you should have more time to do your science rather than the vagaries of data gathering and trying to figure out how to put all these things together. And our hope is that that leads to some improvements in efficiency and reproducibility. One of the intended outcomes of this RCN is to get people together to talk about things that need to be looked at and hopefully stimulate some new collaborations. And so our activities look much like RCNs if you've seen them before, but basically getting people together to talk and to brainstorm, coming up with things like community roadmaps, and iteratively getting your feedback from the community. Just a note for those of you who've been involved in EarthQ, we took to heart the sustainability lessons. And so this is why we've very purposefully tried to build our activities wherever possible into existing organizations like ESIP, like ML Commons, and not starting things that are completely one-off that people get drawn into and then go away with a few years, when the few years of funding is over. This is our team. I'm guessing many of these people are known to you. For those in the ESIP community, you might remember Lynn Schreiber, and so she's our project director, and we have a great team of people working with her to do science writing and to organize great events. And then I mentioned Karen's role and Douglas's role, but also Dan Katz and I are leading together that relationship in FAIR and ML. Our advisory board, some familiar faces. And then here's our logo cloud. A little bit lazy, the Council of Data Facilities is a stand-in for 36 different repositories, depending on if you're counting active or inactive. But what we found and what we proposed, and why I think this was awarded, is some of these conversations occur in pockets, but there was no place to try and bridge some of these activities. And so that is our goal. The opportunities for all of you on the call today, or if you want to tell your friends about this, is coming up soon. We'd like to engage with, especially with data repository owners and CDF members on AI readiness topics. And really, we'll meet you wherever you would like to talk about AI readiness. Even if we at AGU, we had one person in a listening session say, I don't know where to start. And that's okay. There's no expectation that you've got to be expert to have these conversations, because what we're looking to do is eventually come up with a roadmap and to start some of the activities on the roadmap suggested by the community. And again, looking at the gaps and trying to stimulate new collaborations that attack those, if you will. In our the coming year, we'll have a meeting that's co-located at another event. And we, like EarthCube, are very interested in promoting the work of early career people and making sure that they're part of the conversation. And so we've set aside some early career travel scholarships that we'll publicize well ahead of the meeting. Again, everything we're trying to do is embedded in other established groups. If you enjoy the conversation today, I hope you keep in touch with Douglas and Karen. Come back to the data readiness and the machine learning clusters, also the Council of Data Facilities cluster that Karen Stocks co-leads. Dan Katz put in the chat, and I think it's in our session notes too, how to get connected into the Research Data Alliance's Fair for ML interest group. And coming up in March, there will be a virtual session, although I hear it's in the middle of the night because it's when it's convenient for people in Sweden. But with any luck, it will be recorded. And please consider signing up for our newsletter, which will tell you about webinars that we have. And from time to time, we'll have stories that capture things that are interesting. If you don't have time to watch the space, we'll let you know about, kind of just in time, great resources. For those of you that have tools in this space, I know we heard from some speakers before me, or if you're just using ML in your research, we would love to hear about what you're doing. We'd love to promote it as examples when we talk about these things. And we'd also love to feature you in a science story, which is a nice thing that you can repurpose for disseminating some of your outcomes. So I'll leave it there. And thanks again, Douglas, so much for this time to talk about FAR.
Great, thanks, Christine. And with that, I'm going to re-share my screen again. Also, thanks to all the speakers for that very great presentation. And we have a few questions here already, but I would like to point everyone to our session notes for one place I want everyone to look at. So we have the link to the slides, to all the speakers. And so you can always go there to look at the slides if you need more information. And while we are going answer questions, there is a table of have and have nots. So the whole purpose of this session is trying to figure out what do we have and what we're currently working on to advance AI, fail for AI ML in earth science, and what we are missing right now. So if you already have some ideas, please go ahead, put them in at the same time, because we are kind of short on time now. With that, I'm gonna go to the questions. So I think we have a few questions for KJ. So first question for you is that, can you say more about the metadata standards you're using to catalog the contributed data set on Foundry ML?
Yeah, so our metadata standard is based, like our first draft is based on the materials data facility standards, which have been very successful in the materials data space. And for commons fields, we leverage DataCite, like for authors, license, titles, etc.
Cool. And you said your Foundry ML is trying to expand to other domains. So are you going to add other metadata standards or other things into the Foundry ML?
We are very open to adding features and making changes as needed by the as the community, suggests things. So if you have any recommendations or any requests, or you're looking through and thinking like, oh, I wish, they had this, please let us know, because we are so happy to provide this software for anyone who needs it.
Great, thanks. And the next, I think, two questions all speaks about the sustainability. So I'm going to combine those. So what's the plan for the sustainability for the tools, both for Foundry ML and Gardens, and in terms of how you can develop a business plan to preserve the models in long terms, and not just model, the data and all the objects?
Yeah, so all data are open source and they're all available on freely accessible systems that are supported by an Argonne ALCF ALCF Storage Award and Premium NCSA Storage. And data are published on distributed endpoints. So if our repository goes away, the underlying data can still be easily moved to another endpoint. And I recognize that this is a problem the entire community is trying to deal with. So if we think data and software are important, we need these strategies more at the national level to preserve them over multi-decade timescales. So, you know, we're doing what we can on our end, but I think this is like definitely speaks to a bigger problem.
Thanks, KJ. I think that might be a good time to plug in the National AI Research Resource Task Force just released their report and implementation plan. So I think people might be interested to look at that report, and that might be some like national discussion about those research resources and how to preserve those artifacts. And the question is for Geoffrey, what domains would you recommend be pursued for developing perhaps not existing foundation models, and how should we explain foundation models to maximize the use and minimize misuse?
Well, I think we first need to see that we can see that there is a foundation model before we can maximize its use. But if you look in earth science, some obvious types of foundation models, maybe the most obvious are time series, and obviously that spans environmental science and agriculture and areas related to earth science, as well as, say, the earthquake, which I mentioned. And another important type of foundation model is probably built around images. If you look at, we have CloudMass, which is a satellite image classifying snow pixels as one of our benchmarks, but there are obviously huge amounts of remote sensing and related image processing, which we can try to generate foundation models. You can even maybe think of UNet and ResNet as typical foundation models, but I don't think they're necessarily optimized and really have been trained on a broad amount of data. I mean, they all still get trained on sorts of initial things like ImageNet and related data sets. And another area which is of relevance is surrogates. Climate modeling certainly does lots of success with AI surrogates for the simulation, not necessarily the whole simulation, but just parts of the simulation, like in the case of climate, it simulates the cloud component of the model is generated from AI. So I would say those are three foundation models touching various parts of earth science that would be useful to look at.
Thanks, Geoffrey. And one question is for Jensen and others. So does GeoWeaver, or maybe for other speakers might be other, like for example, in Gardens, the ecosystem, can those ecosystems or tools facilitate the incorporate of explainable AI features into the workflows? Jensen, do you want to take a first try?
Yeah, sure. Yeah, GeoWeaver is a pretty flexible tool. It's actually managing your whatever you have. So any features that you can achieve with Python, you can do it in GeoWeaver. It's just a productivity tool. It's kind of like you know, it's a bottom line tool that you can rely on to manage all your like scattered different versions of a code, the histories that are automatically recorded. So you don't have to worry about, you will forget anything in like 2 weeks. I have like a goldfish memory, so probably I will forget tomorrow, and GeoWeaver will got your back. It's like a recording tool. So yeah, any feature like explainable AI, the libraries are all available if you use the Python runtime on your laptop or somewhere else. It all can be used in the GeoWeaver, so it's pretty flexible. And
thanks.
Yeah.
I do want to see if KJ want to jump in to see if Garden has any plan to include those explainability or interpretability features into the ecosystem. So
Garden is still very, very early stages. So I can't be too specific because I don't think we've really gotten to that part. We've talked more about a machine learning workflow of, like how to get from input to output with different, functions and models and connecting them. But it's still all very abstract.
Okay. Geoffrey, do you want to chime in to see if ML Commons have any the development or discussion about the benchmarking, for example, for the explainable AI methods, things like that?
Well, I don't think it has any overall strategy there. I mentioned for the earthquakes, in some sense, we did try to explain the AI by publishing a physics paper which explained explain why the small earthquakes, patterns of small earthquakes could actually predict the large earthquakes. And that we showed the AI, the so-called transformer model in the AI actually picked up that pattern. So, but that's a very specialized endeavor. But it did actually, it was sort of interesting that you could show that if you put in the best physics, you actually got the best explanation. Best prediction, I should say.
Right. I think we have last question from the audience, and then we'll go back to our notes. So how are the large text training data sets created? Can we jump off from tool standards they developed? And how did the data sets in Hugging Face and Kaggle get there? I think that might be a question for anyone who have the insights, who are familiar with those. Geoffrey, do you want to give it a try?
Well, there are certainly more text training sets than earthquakes. So one of the weaknesses, I would say the main problem with the earthquake prediction is that fortunately, we don't have that many large earthquakes. And we don't have that many over a period of time where really detailed information is collected. So whereas for text, the NLP, computer science, academic community, and all the companies in this field, they have generated huge amounts of data sets, and ML Commons itself has sponsored the development of data sets for unusual languages, so that we can extend these NLP methods to languages other than English and French and German and Russian and things which are well studied. So ML Commons is certainly willing to considers creating data sets very important.
Christine, do you want to jump in to see if you are aware of any like tool standards from the other domains or from industry side that can be helpful if the geoscience side want to take advantage of those?
Well, I mean, that could be almost an hour-long conversation. What I've found is that many people are creating their own thing for their own needs. And there aren't many things that I find that span or improve upon other things I've seen in Geo. One thing that we're hoping to look at in ML Commons in the group that Geoffrey leads is seeing if there's value in applying some of the ontologies that other computer scientists have created, to see if this helps document some of these data sets better, but that remains to be seen. There are a few that were created under the W3C, but they appear to be projects for graduate students that were abandoned as soon as they got their PhDs. So, but anyway, TBD. But one of the reasons that, because my background's computer science, one of the reasons that I'm drawn into Geo and groups like ESIP and EarthCube is I see that Geo's doing a lot of things that I think we can use elsewhere. For example, what has been done with the cluster Science on Schema that extends schema.org. And so maybe let me throw it back, not to sound too much like I'm I'm trying to over flatter the Geo community, but I think it might be the opposite in this case.
Thanks, Christine. Jensen and KJ, do you have anything you want to add? KJ, I know you are mostly material science side or computer science side. So do you have any insight you want to share?
Regarding the text training data, I'm not an expert on the language model, but I read a very long post on LinkedIn about explaining how the ChatGPT was graded. Their labelers are very busy producing that much training data. So yeah, that definitely involves a lot of data preparation work. And once the data is created, and I think if you spend some effort, you can transform that into some other format that is more comfortable to your use case. So if you want to ask, can we jump off from the tool standard they developed? I think so. I think if you, well, it definitely requires resources and funding to do that. But if some group can do that for the entire Earth Science community, that'll be great. So how did the data set get there? I think there is some people came up with the idea and they just get the data. That's a lot of data preparation work. So once they upload there, so everybody is using it. And Kangol and the Hugging Face also provide a very good API, which makes them very fair. So that's something that we can learn from.
AJ?
Yeah, and I guess for the first part of this question, how are large text training data sets created? You can actually find some pipelines of this. I had to do this back in grad school to create a corpus and everything for an NLP model. So you can find like a full a workflow of how to create your own text data set and like tokenizing and creating that whole corpus is definitely a process. It takes a lot of time and you need a lot of data just to start with to feed into that. For how do data sets get in Hugging Face and Kaggle? That's actually a really, really good question. And I've never thought to ask that of how people publish their data on both of those platforms. So I don't know, but now I want to look into that. So that's a really good question.
Thanks. Yeah, and one of our colleagues is looking at how Kaggle create a usability score for their data set, which is kind of quite a secret for them because you cannot really find the open description of how they create their usability score. But so that's kind of interesting thing. And so now let's go into our session document here. So I see there are a lot of people typing about, taking notes about it. That's great. And so I would invite everyone to the Google Docs here and then spend 5 minutes, also including our speakers, and trying to provide your thoughts on what do we have or currently working on to launch fair for AI and ML in the Earth Science, and then what we don't have so far. So we saw people putting into have nots, but haven't seen anything putting have here. So if you don't, so we have 5 minutes, just co-writing session at this moment, taking the community wisdom on this document. I'm going to share the link to the document directly here. Sorry, my foster dog is making a scene here. I've been on Zoom for 6 hours straight.
I'm guessing you're not the only one, Douglas.
And I also add a column of like give thumbs up if you just want +1 or something on the side. If you agree with that and you don't want to like repeat that answer, you can do that too. On the contents, I can basically get some of my colleagues wrote specific items.
Not it.
I think, okay, yeah, thanks for everyone for putting in. This document will be available for anyone to still adding it even after this session. So if you think about anything, waking up in the middle of the night, maybe write down on notes and then come back later after you during your regular working hours. So, and I do have a question for all the speakers and to think about, because right now a lot of development is focused on Python, and tools and other things are in Python. And we're seeing, I know within NOAA, there's a substantial group using R, and there's also development in Julia. And so how some of the progress in the Python ecosystems can maybe be borrowed or be reused in those different research community who are not using Python. For example, the GeoWaver or the Garden, the Foundry ML.
Yeah, I can go first. Yeah, that's a very good question. We have been asked by our community, so when GeoWaver can support R. We haven't yet, but yeah, we are trying, because Python is the most popular language for AI, and R is probably the most popular for like making charts and making data visualized. And we also have so many people using the HPC who are more familiar with the shell script and also Fortran. So how to make all these languages work together is actually one of the benefits of the use of the GeoWaver, because it supports shell, so it basically supports everything. It's like you can type all your command line into the shell scripts, and either it's R, Fortran, or other language, you can put it together into one workflow. So once the Python finishes the AI work, then R can be followed to make the result visualized. I think that's how to make all this work together. But if you want to make the features of the AI available in R, I think that'll be a bit difficult because you have to rewrite the TensorFlow and PyTorch. That'll be a lot of work.
Well, R also has an API to interact with Keras and with TensorFlows and with Torch. So
Yeah,
there are people
yeah.
trying to move some things into between different words.
Yeah, but most of the source code based on TensorFlow and PyTorch are written in Python. So if those people want to reuse them, they have to write again. So that's a big problem.
Thanks, Jensen. Any other insights from speakers?
There is a project called MLIR, which is the intermediate representation for machine learning, which is used by at least the dominant industry vendors and a lot of the CS community to generate language independent systems. I mean, because there are several languages, other languages. Rust is another language several people like for machine learning. And so I think MLIR is built on what's it called, LLVM, which is the standard compiler system, generic compiler system. So there's quite a bit of interesting activity here. Another sort of important point is that Python only runs well because actually most of the code is written in C++. That's where all the libraries run, because then that runs real fast. And Python is the high-level interface where the performance issues are not as important.
Thanks, Geoffrey. KJ, yeah?
I guess this is related to the question, but not quite the same as answering it. But we, when we have been talking to people in our community who use Foundry, because Foundry is Python based, we found that there are people that either want to use Python and use the SDK, or it's people who are like, I don't want to touch the coding part. I want to look at things. I want to look at things on a website. I want, to be able to just run it in a notebook. So for us, it's not really looking at different programming languages. It's like, we've got kind of two sets of users, those that feel comfortable doing software development and coding and using Python, and those that don't. And so I think that's kind of the two paths that we've been focused on.
Right. Thanks, KJ. Christine, any final thoughts on this question?
Actually, I was busy working ahead on one of the other have-nots and was adding comments to the document. So sorry to be the bad student, but
No, I was just like,
but on this topic, this did come up when we were building the notebook directory, because geos so are heavy, but all the tools and resources are really in Jupyter. And then let's not forget, there's also the whole group of people using MATLAB in geo, which, you know, the people that predate the art people, depending on when you did your training, or some libraries. And so this came up with when we did the notebook competition in EarthCube over the past few years. I did put a link. There's a comment that it's not labeled like here's something for machine learning, but you can go through and you can find some. And we did actually have one notebook make it through the peer review process that is based in R. And so it's a challenge. And sorry,
thanks,
Dan probably has something more useful to say about this, since he was involved in building this this whole directory.
Yeah, then I will give it the last comments to you before I close the session. Then go ahead.
Okay, thanks. I was just going to say that I mean, I like this idea. I think is good. As Christine was saying, we tried to offer the opportunity for people to create notebooks in different languages, and most people chose Python. So that just seemed to be what the people that were responding did. But on the other hand, I mean, I think we could do this in multiple languages. And the thing I was going to suggest is, I don't know what the right conference would be, but at some future conference, it seems like there would be a nice possibility of somebody offering a track that's for ML notebooks. We know we have the mechanisms to review them. We have the mechanisms to publish them. We could create a venue and actually do this and build this if somebody wanted to take the lead on organizing such a track.
So we do actually have funding through the Decoder CSSI to continue this notebook competition, but targeted at specific geo communities. We could partner with them. I'm a co-PI, and do what you suggest, Dan.
Right. Thanks. That's a really nice discussion. I really learning a lot, and also want to remind everyone that there's the resource section in the notes. And so if you want to share any resource, please feel free to add them into here. And also want to remind everyone that the two clusters, data readiness cluster, you can join the listserv in the link here. Machine learning cluster, you can do the same. And the next meeting for the data readiness cluster will be February 21st, and for machine learning cluster will be on Friday, February 17th. And with that, I want to thank Annie and Mike, who has been supporting this session, and my session co-conveners, Karen and Rob, and the 4 speakers. And with that, Annie, do you have any closing wisdoms for us?
No closing wisdom, maybe a closing announcement, just that we look forward to seeing everyone for our last day of the January meeting tomorrow, Friday. We will have a closing plenary where we'll recognize some of our peers with some awards. And yeah, we just look forward to seeing all of you. Thank you for your engagement throughout the week, and have a lovely evening.